In this video, we are going to look at numbering system, and we're going to look at converting numbers between different systems. So the first conversion we're going to do is going from denary to binary. So denary is the number system that we use, and we need to be able to convert this into binary, which is ones and zeros. So on the worksheet, on this worksheet, I've taken some numbers. So we've got 5, 254, 6, 131, and what we're going to do is we're going to convert this into binary. So this is our denary numbers here. So step one is to create a table. So the table has to have 8 columns, and I've got 1, 2, 3, 4, 5 rows, and these rows are going to be used to put the answers. So you start off with the right hand side and you put the number 1, and then that number is going to double each time. Why? Because it's 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, so on. So all you need to know is it starts off with 1 and goes all the way to 128, which is using 8 bits. So 1, 2, 4, 8, 16, 32, 64, and 128. Next thing I'm going to do is I'm going to try and make 5 using these numbers. So one way of thinking about it is imagine that these are coins, okay, and we are going to use these coins to make 5. So if we don't use a coin, we put a 0. So we've got the number 5. Would you use a 128 to make 5? Well, you wouldn't, because it's too big. So we're not going to use 128, we put a 0. Would you use 64? Nope. 32? Nope. 16? No. 8? No. Would you use a 4? Yep, you would use a 4. Would you use a 2? Well, if you use a 2, you're going to get 6, and that number is obviously going to be too big. So what you need to do is you need to use 1. So 5 in binary is 0, 0, 0, 0, 0, 1, 0, 1. Now for the worksheet, you only need to put the numbers that you need. So 5 across. So you only need to put 3 bits, and you put the 3 bits from the right hand side. So 101. You always put it from the right hand side, not the left, because that's the most significant. Right, number 13. Right, what do I need to make 13? So to make 13, I need an 8, a 4, that's 12, and a 1. Okay, so the rest are going to be zeros. Okay. 131, that's a big number. So what would I need? Well, I need a 128, so I put a 1 there. So if I've got 128, how many more numbers do I need? 129, 130, 131. So I need to make 131, and I need 3. I need 3 now. So 64, I don't need. Does 32 fit into 3? No. Does 16 fit into 3? No. Does 8 fit into 3? No. Does 4 fit into 3? Nope. There's 2 fit into 3. Yep, we'll have 1 left, and there's 1 fit into that. It does. So 254. How are we going to get 254? So we've got to use the headings above, and we've got to use those numbers to make 254. So we've got to use nearly all of them. 128 and 64. That will be 192. This will be 224 plus 16, 240 plus 8, 248, 252. 254, that's it, put 0. So you may want to use a calculator if you think that will help you, but 254 is the following numbers. So 1, 2, 3, 4, 5, 7 ones and a 0. So key things to remember. Number 1, make your table starting from 1 going into 128. Number 2, find the number that you need to convert, in this case the number 5. And number 3, try to make the number 5 using the coins above. You can only use the coin once. So if you use it, you put a 1. If you don't use it, you put a 0. And that's it. Now, to go from binary to denary, this is what we do. Step 1, we create our table starting from 1 going to 128. We then start from the right hand side, because that is the least significant. We don't start from the left because that's the most significant, because if we are trying to convert the following number 1011, well, that's gonna give us an incorrect answer because we've started from the right hand side. So we started from the left hand side, and that's the most significant. Start from this side, So if we're converting 10, 11, we put a 1 there, a 1 under the 2's column, 0 under the 4's column, and a 1 under the 8's column. The rest we can just put zeros, we don't have to worry. Okay, because you've got to represent your answer in the exam as 8 bits, but on this worksheet you don't. We now look where the 1's are. So there's a 1 under the 8's column, and there's a 1 under the 2's column, there's a 1 under the 1's column. We add these numbers up and we should get the Denary value. So 8 plus 2 is 10, plus 1 is 11. Okay, so going back to this, this number 7 across is 11. So we've got 1, 2, 3, 4 ones, 0, 1. So we start from the right hand side. So we've got 1, 0, and then we've got 4 ones. 1, 2, 3, 4. The rest are going to be zeros. We look where all the ones are. There's a 1 under 32, 1 under 16, so that's 48, plus 1 under the 8s, so that's going to be 56, 60, 61. Okay. And then this one is 1, 1, 0, 0, then 1, 1, 0, 0. So what is this? There's a 1 under the 32 column, 1 under the 16, so that's 48, plus 2, 50, plus 1, 51. To just double check, so that's 48, 50, 51. So, key rules. Number 1, make your table, starting from 1, going to 1 to 8. Number 2, always start from the right hand side because that's the least significant side. Try to put your number the way you see it on the sheet, and then you look where the ones are. So number 3 is where you look where the ones are and then you add them up, and that's it. The next conversion we're going to do, you don't have to complete this section, but if you want to have a go, it will help, is looking at hex to binary. Now hex is another numbering system that computers use. It's base 16, so that means it's going to use 0 to 9, which is 10 numbers because computers use 0, and then the letters A to F. A is going to represent 10, B is going to represent 11, C is going to represent 12, all the way to F, which is represented 15. Why do computers use hex? Well, you can represent large numbers. 4 bits, 1 hex can represent 4 binary bits. And also, it's easy for us as humans to exchange the numbers, and it's easy for us to remember, especially if it's using things like letters and so. So in order for us to convert hex into binary, we've got to make 4 bits. Remember, 1 hex is equivalent to 4 bits, so we do 8, 4, 2, 1. Now on this sheet here, you've got things like BE, 65, or F. So let's do BE. So B is going to represent 11 because we've said B is 11. So we've got to make 11 using the following coins or numbers. So we need an 8, we need a 2 and a 1, and we're not going to use a 4. So if we add all of them up, that should give us 11. 8 plus 2 is 10, plus 1 is 11. So E is, if we have a look at our table, E is 14. So we need to make 14. We need an 8, we need a 4, that's 12. We need a 2, that's 14. And we don't need a 1, so that's going to be 14. Okay, so if we put this together, it would be something like 1, 0, 1, 1, 1, 1, 1, 0. So that's the binary equivalent of BE. Let's do 65. So 6, we have to do 6 first. So 6 is going to be no 8s. We need a 4, we need a 2. So that's going to be 6. And to make 5, we need to use a 4, an 8, a 2, and a 1. So that's going to be 0, 1, 1, 0, 0, 1, 0, 1. That is representing 65. Okay. Now we will cover this in lesson. That's why I've kind of rushed this through. So try to have a go. If you can't do it, it's not a problem. In lesson we're going to cover this. But key things to remember is that hexadecimal is 0 to 9 and A to F. Make your table going from 1 to 8 and then try to represent each one. So if you put a space, it makes it easier to understand. That's it.